Hey everyone, welcome back. In the last video, we got some data from our database and we put it into the shape that it needed to be in according to our type definition for user in the schema that we created for our project. Now, if you don't remember, our schema looked like this. All right, at least the type for the user was set up this way. All right, and it took a little bit of effort to do that. We had to get the data from the database, and then we had to we got that data using SQL queries that maybe not all of you are familiar with. I know that I'm not an SQL master, I'm far from it. And it was a little bit convoluted the way we got that data and we put it into the shape we needed it to be in. And overall, we've just been sort of exploring. We haven't really tried to give our project any structure. This will be the first time we actually start thinking about structure, and we'll use an ORM. In particular, we're going to use Sequelize, and that will help us sort of organize our project better. We'll be using models to define our tables in our database, and we'll also be, happy using this ORM because that will abstract away the complexities of writing raw SQL queries. It allows us to basically use JavaScript or TypeScript in this case to interact with the database and get the data we need. So if you've never used Sequelize before, and in particular if you've never used it with TypeScript, this is going to be a little bit of a challenge for you, I assume. But probably by the end of this video you'll feel pretty comfortable with not only using Sequelize and TypeScript together, but also bringing those two technologies into a project and using them with GraphQL. Anyway, that's a lot of talking, so let's go ahead and take a look at the documentation for Sequelize. And I'm using version 6. Right, for setting up and getting started, you basically just need to add Sequelize as a dependency. We're using Postgres, and we've already added PG, but we'll need to also add this PG store. All right, so go ahead and add those dependencies now. All right, we'll just check to make sure they're there. All right, good. Also, we'll need the Sequelize CLI. All right, and that's a dev dependency. And the Sequelize CLI basically is a tool that will allow us to bootstrap our project. It'll give us some files and folders that we can use so that we don't actually have to write all of our code from scratch. And you'll see what I mean in a minute here. Let's go ahead and take a look at the documentation again. If you go to the section called Migrations, right, you'll see it tells you to go ahead and install the CLI, and then you can initialize a project. You can do this project bootstrapping thing that I just mentioned, and that'll give you a few folders that are very useful. So let's just go ahead and run that and see what it gives us. And it's not npm, but it's npx. Sequelize, CLI, init. Alright, so it tells us that it created a models folder, a migrations folder, and a seeders folder. Alright, so if you look up at the top at the migrations folder, it's empty, but we can auto-generate, not auto-generate, but we can use a command with the Sequelize CLI to generate migrations. And migrations are good for keeping track of changes to the database for an app that, if you're using Sequelize in production. For today, we're just going to focus mainly on using models to generate our tables in our database. So we'll ignore the migrations folder. And if you look at the config folder, they give you a file called config.json, and this is where we set up our database connection. All right, now you can add in all of your stuff directly, but so far we've been using .env and hiding our connection string variable values, and we'll continue to do that here. But since this is a JSON file, we'll have to make it a JavaScript file to do that. All right, we'll rename it. And we'll be using .env, so we'll require it here. All right, and just to make sure that we're pulling in the values okay. And we'll just check the database name. If you remember, the database name that I was using is TS-SQL. Probably should change it to TS-Sequelize or something, but that's not really important. So we'll go ahead and run this file. All right, the config folder is in our root, and the main file is config.js. All right, so we see that .env is working for us. Good, so you can get rid of that. Actually, copy this. All right, so that was the database name, so we'll put that here. We'll also need our password. So that was db pass. And we'll need our username. So that was db user. Okay, and you'll change the dialect if you're using Postgres to Postgres. We're still using localhost, so. All right, so that should do it for the setup there. Now, just to check our database connection, we can go into our index.ts file in the src folder. All this code that we had in here before, you can just get rid of it. Not all of it, sorry, I shouldn't say that. All of this commented out code and unused code. Just get rid of it. All right, so with Sequelize, you can run a function called sequelize.sync or model.sync, and what that'll do is that'll take any models that you have defined, which we don't have any defined yet, and it will use those to create tables in your database. All right, so if you look at the documentation, under Model Basics, if you go down to the section called Model Synchronization, you'll see what I'm talking about. For example, if you have a model called user, and we do have a model, or we will have a model called user, and you run the function .sync on it, right, it says this creates the table if it doesn't exist and does nothing if it already exists. Right, but if you want to create tables for all of your models, you can use this function here. That's sequelize.sync. Okay, so going back to our code, all right, we'll need to, just to check our database connection, we'll need to bring in our database connection from, let's go back to that file, from here, this index.js file, which is in our models folder. Right, what this does is it basically makes the database connection along with the models available throughout your project just by importing this file. All right, so you can see that's done here. All right, so if we go and we add that, all right, so it's an index.js file, so we don't need to actually put it in the path. It's a default file for this models folder. So we should be able to do db.sequelize.sync. And then we can add this inside of here. All right, and then if we run our dev server, we should be able to see if we're connected or not. And by the way, I've gone and dropped all of the tables in my database. So since we're starting from scratch with this Sequelize ORM, so you should probably do the same if you're following along. All right, so let's run the our script, our dev script, and you remember, hopefully, that it was just this right here. And we're using ts node dev to watch our files for changes and to, do hot updating, real-time updating for us. So I'll go ahead and run that. Okay, we got an error already. Okay, so the first thing I forgot to do, it says it can't find this module. Right, you can see it says config.json. So if you go into this config.js file, well, you don't have to go in here actually. We changed this file from a JSON file to a JavaScript file. So in this index.js file, which is located in the models folder, you'll need to make sure that it's aware of that update, which I forgot to do. Okay, so let's try this again. Okay, so you can see here that our database is connected. We see this sort of test SQL query, right? And that's letting us know that the database is connected, and also you can see that our server is running all right. And if we go to localhost 4000, which is our GraphQL Playground, and we try to do a user's query, say we want to get the names of all the users. And if we try to run this, what happens? Nothing, of course, because we completely cleared out those tables in our database. So hopefully that's where you're at right now. Okay, so let's create our first model. And stop our dev server here. If you check out the documentation at Sequelize again, in the migration section, they give you this bit of code right here, and this allows you to generate a model. So go ahead and copy that. Right now, we're going to create a user model, so you can leave the name as user and the attributes. You can add them all right now, or you can add just one and then we can add the rest in the file later. But you need to add at least one, otherwise it won't work. So each user definitely has a name, and that is a string. So we'll go ahead and do that. Okay, so it tells us it created both a new migration and a new model. Just ignore the migration for now. And we'll take a look at the new model, which is in the models folder. Right, it's called user, and the file name is user.js. If you look in the index.js file, you can see that what it does is it looks inside of its own directory for all files of type JavaScript, and then it goes through and does stuff with them. Right, in particular, it requires for each model, it requires it, and it injects both Sequelize and the data types so that they can be used in the model, and you can see that here. All right, but everything's JavaScript right now, and we want to be using TypeScript, so the first thing we should do is change this user.js file to a TypeScript file. And then once you do that, you see you've got 3 errors here. Sequelize says implicitly has an any type, and so does data types, and so does models. Now in general, you don't want to just go ahead and use any. You want to do more strict typing, but Sequelize is a third-party library. We're trusting it, so we should trust that it's okay to use any with these things here. So for example, it does allow you to do a quick fix. You could just click here and say infer parameter types from usage. So if you do that, it says any. So it's just going to use any anyway. It does the same thing with data types. All right. And then for models, what does it give us? Infer parameter types from usage, any. So again, you might feel uncomfortable using any, but if you go to the TypeScript documentation here, it says TypeScript has a special type any that you can use whenever you don't want a particular value to cause type checking errors. Now that's pretty ambiguous and not very good, because what happens is if you start thinking this way, you're going to start using any too much. Right? And if we go back here, we go to this deprecated page, and when it talks about the any type, it says here, in some situations, not all type information is available, or its declaration would take an inappropriate amount of effort. So it's kind of funny, because if you start thinking that everything is an inappropriate amount of effort, you'll never do strict type checking. Right? So you shouldn't really adopt that way of thinking, and it's easy to see why this page has been deprecated. But there is an important piece of information. It says situations may occur for values from a third-party library, right, where not all type information is available, right? And then it says here, in these cases, we might want to opt out of type checking, right, because we're using a third-party library and we're trusting them. So anyway, that's probably saying a lot more than needs to be said about the type any, but that's basically our motivation for doing what we're doing right now in this user model file, right? So anyway, since we're using ES6, let's go ahead and use an import statement here. All right, so we import this model class from Sequelize, and then we extend it to create our user class here, right? And if we go back to the Sequelize documentation, in the TypeScript section, it says you can use an interface called user attributes with your user model. So just copy that, and you can paste it in right under your imports. All right, but our ID is not going to be a number. We're using UUID, so it's just a string. Our name is a string. We also have an email, which is a string, and then a password, which is a string. Okay, and then we'll want to implement these user attributes. And you can see here that if you just add this right after model, we're not using the user creation attribute, so you can get rid of that. And then we want to implement them. So right after that bit we just added, you can add that. Now it says that we've incorrectly implemented the interface user attributes, so let's rectify that. So we need an ID, right, and that's required, right, so we'll make it non-nullable, and that's a string. We need a name, again non-nullable, string, email, non-nullable, string, and a password, non-nullable and string. Okay, we'll get into defining our associations in a minute. Let's go down to the part that says user.init. So when we generated this model, we only specified the name attribute, but we need to specify all of them. So we'll start first with ID. All right, and that will be type data types dot UUID. All right, and we want the default value to be UUID v4. And you can go up here and you'll see that it's auto-imported that for us. Right, and you can see also that TypeScript is not very happy with things right now, but basically that's the way it is. As soon as we get all of our required fields in according to our interface, our user attributes interface, then finally it'll stop complaining to us. So we also want this to be not nullable, so we say allow null false, and we want it to be a primary key, so we say that's true. All right, for name, it's type data types string, allow null false, email type data types string, allow null false. And one more thing, before we check to see if a user was in the database or not by looking up their email, we check to see if there was an email address that was already in use before creating a user, and if there was an email address already there, it wouldn't let us create the user with that same email address. We can take care of that through Sequelize right here just by setting this field unique to true, and that saves us a little work. All right, and then finally we need password. Okay, so are we getting any more errors here? Right, we've got this error here. So it says it doesn't exist on type string any. So if we go up here, we can see that what we asked TypeScript to do for us kind of hurt us, right? So what you can do is you can get rid of this and just let this be any, all right? And that should get rid of that error, and it does. All right, we've got one more error. For some reason I'm not seeing it. Oh, here it is. And that's just because we forgot to add a comma. All right, so TypeScript seems happy with this file as it is, but we shouldn't be happy with it because remember, we want to, at least for now, we're only thinking about a user and a project, right, as a model, right? So the first thing we created already was the user model. We'll also need to create a project model. And a user is related to a project in the sense that a user can be assigned to a project. And a project is related to a user in the sense that a project can have one or more users attached to it, right? So we have this many-to-many relationship. So all of our users can be assigned to many projects, and all of our projects can have many users. So here's where we define that association, right? We have a many-to-many relationship, so what we do is we take our user class dot belongs to many, so you can find that. All right, and it belongs to many projects, right? So this is kind of annoying. So to get at the project model, we're importing it using this right here. So go ahead and use models.project. All right, and the relation happens through a junction table. Remember in our last video we created this table called assignments, and that related projects to users, or it associated projects with users and vice versa. So we're going to create this association through that junction table, which we'll call this time project assignments. Okay, so that's our relation of a user to projects. And no errors here, so this is good for now. So what we'll want to do now is create the project model. So see if you can't get that model generator command back. This time the name is not user, it's project. Alright, and we'll just give it the one attribute for now. And that will be its title, the project title, and that'll be a string. Alright, so it tells us it generated our model for us. So if we look in our models folder, we see the project file. Alright, and it has the exact same structure as the user model did. So let's go ahead and make this TypeScript. Fix those 3 errors we got before, and we'll just type it in manually. Don't let TypeScript infer the data type because it messed us up last time, so just use any. Again, Sequelize is a trustworthy third-party library as far as we're concerned, so we'll just go ahead and trust it and give these types, or make these any types. All right, again, for consistency, let's use an import statement here. All right, so last time we created an interface called user attributes. This time we'll create one called project attributes. Sorry. Helps if you can spell correctly. Alright, so this will have an ID, and for our project, let's just let the ID be an integer. Alright, so in JavaScript that would be a number. So project 1, project 2, project 3, and so on. Alright, title, which will be a string, and status, right? So the project could be active or inactive, on hiatus, whatever you want to use. It's a string. All right, we'll want to use it in our model class. Right, again, TypeScript wants us to correctly implement the project attributes, so we do that. ID is required. That's a number. Title. Right, let's make it required. Number. Why does it not like that? Sorry. What am I thinking? Title is a string. Okay, and then of course the status, which we'll just make required. Okay, let's go down here. Again, we've only added the title attribute. Let's also take care of the ID. This is integer. Alright, it's non-nullable. It's a primary key. And what we want to do is have Sequelize automatically generate a new project ID value just by auto-incrementing, the integers, right? So if we start off with 1, the next one will be 2, the next one will be 3, and so on and so forth. So use auto increment true for that. So for our title, the type, data types, string, allow null, false. Add your comma here. And then our status. You can see we haven't fully defined status yet, but TypeScript stopped yelling at us because it saw that we were basically about to implement our project attributes correctly. Okay, so we've got no errors. Let's define our association, which is basically the same as the other one, just in reverse. So this time we're starting from project, belongs to many, users. All right, so we just use the model name. When we create the table in the database, it'll actually pluralize it to users. And it does that through the junction table project assignments. That's what we called it in the other model, right? Yeah, project assignments. Good. All right, so these two models are set up and ready to go. So the nice thing that the Sequelize.sync does for us, right, that creates the tables based on these models if they aren't already created. So once we run our dev command, excuse me, we should be able to see those two tables, the users table and the projects table in our database. But also we'll see a third table, right? Because we've defined this association, project assignments here and here, it'll automatically create a table called project assignments, and it'll infer the attributes, right, which will be a user ID and a project ID, right, because it's looking at the primary keys that we've set up, you know, here and here. So that's nice. It's a little bit of magic for us. Basically, it's some work abstracted away that we don't have to do. So if we run our dev command, we should be good. All right, but it didn't do that for us. So why not? Okay, I think the problem is here in the index file. Right, we told it to look for files of type JS, but all of our models are file type TS, right? They're TypeScript files. So go ahead and change this. But before we do, let's stop the dev server. Right, change this to TS, and let's go ahead and make this file itself, this index.js file, let's make it a TypeScript file. Alright, so you can see that in doing that, we get 9 errors here in this index.ts file, and then we get an error in here, right, because it doesn't like the import. So if we go through this index.ts file, first of all, the thing that we're exporting is this DB, right, database. We're defining it here as an object, but if we do that and we export it, it's not going to really be clear on this side to TypeScript what it is, right? And there's a lot of things it's not going to let us do, and it's going to start asking us to do strict type checking. But again, since we're trusting this Sequelize third-party library, we can just let the type of this be any. And if we do that, we see several errors go away, and we're just down to 4 errors here. So again, Sequelize, we can hover over it. It says that it has an implicit type any. Let's go ahead and use quick fix. Infer type from usage, we get any, so that's what we thought it would be. This one might be a little surprising to you. Quick fix for parameter types from usage, string. All right, and then here, any. Okay, so that fixes everything in this file. But if we go back to our index.ts file where we're bringing in DB, it says here, index.ts is not a module, right? Yet we're using module.exports. So we can fix that by using default export. Sorry, it's the other way around. Export default. And that gets rid of the error in the main index.ts file. Good. So now if we run our dev server, if we run dev, we should be able to see that our tables get created based on the models. So let's do that. Okay, good. So it says here, create table if not exists, projects. So it created a projects table for us. Right, and then it said create table if not exists, users. Right, and it created a users table for us. And then here it said, or it says create table if not exists, project assignments, right? And that's because we set up that association. So we should see 3 tables in our database: users, projects, and project assignments. So if we refresh our tables, we do see the 3 tables. We see users, which has all of those attributes. Each column is defined according to an attribute. Right? ID, which is the primary key, UUID, name as a string, email as a string, password as a string. And then it automatically creates 2 timestamps. One when the record was created, which we haven't. Once we insert a user into this table, it'll create a timestamp for that, and it'll also have an updated at timestamp. Project, right? Same thing. It gave us an ID column with as an integer, or the ID will be an integer, and it'll be the primary key. Title is a string, status is a string, and then our automatically created timestamps. And then finally, project assignments, and this is the interesting one because it creates these 2 columns for us, right? It creates one called project ID and one called user ID based on our primary keys of our project and user models, right? And it also uses the correct type, right? This one is an integer and this one is a UUID. And these will be existing values. This integer will already be in a project record, and this user ID will be in a user record. Right, and these 2 primary keys are actually combined together to make a composite primary key, meaning that if you already have an assignment where you have a specific user ID and a specific project ID, and you try to use those 2 again together, it won't let you create the assignment. Right? And basically what it's saying is that you can't add a user you can't add the same user to a project twice, right? And that's doing some work for us that we don't have to do later by writing out some logic to take care of it. So that's nice. All right, so if we go back to our code, go ahead and stop your dev server. We'll want to now add some records to the table, or to the tables, right? We'll add some users to the users table, some projects to the projects table, and we want to add some project assignments to the project assignments table, but we're going to need a project assignments model to do that, so we'll have to create that model now. So if you can get that model generator code back, and the name, we're just calling this project assignment. Right, remember the model is not pluralized. The table will be the table name will be automatically pluralized. All right, and just give it one attribute for now, and that will be the project ID, but we have to be careful. Right, we have to set up that attribute in the same way that it's already been set up, or in the way that it was set up as in the database. So if you take a look at your project assignments table, project ID, right, the P is capitalized and the I is capitalized. Same with user, the U is capitalized and the I is capitalized. So we'll have to set it up in that way. Set up our project assignment model in that way. All right, so we lost that command. All right, so that's a bit of a pain. Go get that again from the documentation. Remember, that's under migrations right here. Copy it, paste it in. All right, so it generated that that model for us as well. All right, let's make that a TypeScript file. Excuse me. Fix our errors. Okay, and this time we'll need an interface which will be called project assignment attributes, just to be consistent with our naming. All right, it'll need a project ID, so be careful how you write it out. It should be capital P and capital I. And this is a number. And we'll need a user ID, which is a string, because it's a UUID. Now, since we already have an association between project and user, we don't need to worry about defining anything here. Don't know what I was thinking with that. Now, the database table that we have, it already knows, or it set it up where this was a primary key. So we still should tell it to do that because it's going to look at the database again, and there's a chance that it might drop that or it might lose that attribute. So add it here just to make sure. All right, and this is also acting as a foreign key. All right, and the way we set that up is by saying references. All right, and then we define the model. All right, and we'll use a table name here. So this reference is projects. The key is ID, right? Because that's the column name for the ID in the projects table. All right, that should be good, and we'll do the same thing for user ID. Okay, so that should be good. We're not getting any errors. We only have these two attributes to worry about. We've set up our foreign key references. Good. All right, so now what we can do is we can create some test values or test data. But rather than have you watch me do that, I'll go ahead and create that, pause the video and create that, and then come back, and then I'll put it in a gist so that you can just grab it and paste it into your project later. Okay, so I've added a gist to my my GitHub account. So if you take a look here, you can see this gist I've created. It's got just some seed data that you can add to your project. You can create your own if you like. I'll just put a link to this gist in the description below the video so you can use it to save yourself some time. And so I've got a file for users, and I've put this in my seeders folder. All right. Eventually you can just get rid of all of this, but for now the seeders folder is coming in handy. Now I've got this file of users. I've created 3 users. Right, you can see that the user ID is a UUID, so you'll have to import that in. But I've got a list of projects in a file called projects.ts, and that has 3 projects. Right, we only needed to enter the title and the status because Sequelize will automatically add the integer ID value and auto increment it for us. And then I have a list of assignments. Now here, what you'll need to do, and even these numbers you might have to change. I'm assuming everything will go smoothly, and because I have 3 projects set up, I'll have a project with an ID of 1, a project with an ID of 2, and a project with an ID of 3. So that, in anticipation of that being the result, I've already set up the project IDs, but I may have to change this in case there's an error, because sometimes if there's an error when it tries to insert a record and then you do it again and it works fine, it'll auto increment past that integer value that would have been there had there not been an error. It could go like 124, for example. All right, so you may have to change this. So just know that these are fluid values that you'll get from your database. Same with the user ID, right? Until we create the users in the database, we won't have a UUID value available. Right, so we'll need a function that will create, users. It'll add and insert the records for projects and insert the records for project assignments. So in your utils.ts file, which is in your src folder, remember we had all of this stuff here from last time. We're not going to need it. All right, so what you can do is just go ahead and get rid of everything all the way down. Or you can comment it out if you like, just in case. Actually, I'm going to show some courage here and just delete it. All right. So I guess I can always Control-Z it back if I need it. All right, so we're not importing the DB this way anymore, right? We're getting it from the models folder. So we import DB from models. All right, and since we're creating the user IDs in another file, we can get rid of this. All right, so we'll need a function that adds users to the database. So we'll say all right, so we'll need to import that list of users. Named export. So we'll map over that list of users. And then for each user, we'll use the function create, Sequelize function. Right? So its usage is just db.model, which will be user. And remember, we're bringing in the model with db dot create, and then just user. All right, we're going to do that for each user. We'll do the same thing for projects. Almost finished here. And don't forget to use the correct model. So this is the project model. And this is the project assignment model. Sorry, I'm getting a phone call here. Let's go ahead and pause. Okay, so these three functions should be good. And then in our main index.ts file, we can bring all of these functions in. So we need users. Whoa. Yeah, it was create users. Sorry about that. Create projects and create assignments. All right, let's run these one at a time. Actually, let's just run them all together, who cares? So if we run our dev command, hopefully these will all get added to the database correctly. Okay, so it looks like we're getting an error here. Getting a few maybe. So here it says we've got a database error, invalid input syntax for type UUID, add ID from database. All right, and where is that? Okay, I know what I did wrong. Completely foolish here. I said we were going to need to do it and I didn't do it, so let me go ahead and stop the server here. If we take a look at our database, we'll probably have users and projects. So if I take a look at the user values, the users got added, that's fine, and the projects got added, I'm sure. Yes, they did 1, 2, 3, that's good. So our project IDs are going to be fine the way we had them set up. But the project assignments, if you look, it didn't add anything. And the reason it didn't is because, as I said before, you need to add the ID from the database, right? So the project IDs will be correct, right? So this project ID would be the site upgrade login page. This would be like a site upgrade user dashboard or something like that. And then this would be a server migration. Actually, no, we're not even going to use the server migration. So project ID of 1 was the site upgrade login page, I believe. Project ID 2 was the user dashboard upgrade. And if we take a look at the projects, we can see that's true. Actually, yeah, number 2 is the user dashboard. Number 1 is the login form upgrade. So those are okay, but we also need the user ID values. So if you go back to your users table, and say for Octavio, we'll want to assign him to 2 projects. So get that UUID, copy it, and then paste it in here. So we want to assign him to project 1, and we'll also assign him to project 2. Okay, and then we'll want to assign Farah to project 1 as well, so we'll get her ID. And we'll just assume Peter's on vacation for a little while. He's not available. Okay, so that should be good. So if we run, we don't need to run these. So if we just run create assignments, that should add those user assignments to the project assignments to the project assignments table. So let's try it. All right, good, no errors. All right, so we have 3 insert into statements all into project assignments. So those assignments should be there now in the database. That was here. All right. Good. Okay, so we have those 3 assignments, right? We've got 2 different people assigned to project 1, and then 1 person assigned to both projects 1 and 2. Okay, good. So now what we'll need to do is we'll need to query for, because what we wanted to do ultimately was get all of the user information we could get and display that list of users in our GraphQL Playground, right here. Right, we're not able to do that, so we'll need to make sure we can. So go back to your code, right, and in your utils file, and actually just make sure that you have all of these commented out at this point. And in our utils file, we need a function that gets all of the user info, right? And remember before, we had to use several, a couple of function calls and a sort of convoluted SQL query using two inner joins. This time we can use a single function call using Sequelize, which is nice. So we can define a function. And let's go ahead and stop the dev server here. Call this get users. Let's make it asynchronous. Not spelling very well. All right, and then there's a function in Sequelize called findAll, so we can say db.user.findAll. Right, and we could just run this and then see what we get back from it. And so we can say so let's see what happens when we run it. It looks like we've got an error here. It says models default.user findAll is not a function, it's a type error. So if we Alright, so this should be capitalized right here. Alright, let's try this again. Okay, so it did find the users for us. So you can see we've got Farah, we've got Octavio, and we've got Peter. All right, we should probably make this more readable. Fortunately, when we do that, it puts it all here. So it's not really that much more readable. All right, so anyway, we're getting the users, but all we have, and let's undo what we just did here. All right, all we have are users' ID, name, email, and password. In fact, we don't really want to keep the password, but that doesn't matter for now. We don't have the list of projects that we want, right? So we want to bring those in too. And since we created that association, we can do that actually very easily. So here what we can do is we can include the model, and that will be db.project. Then attributes. Well, let's just do this for now. See what this gives us. That's why I don't like to leave the server running. It does that. All right, so you can see for a user, say like Peter, now we can see there's a list of projects. Remember though, he's not assigned to any projects, so this should be an empty array. But with other users, such as Farah, right, you can see we're getting it in this shape right here. If we were to make it more readable, like we did before, you can see it starts right here. All right, so we've got an ID and a name, that's Octavio. We've got his email, we've got his password, we've got the timestamps, and we've also got that list of projects right here. He's assigned to project 1 as we specified. But also we're injecting the list of assignments as well. We don't want those. All right, so what can we do here? Well, what we can do is we can exclude those attributes from our junction table that we don't want to see, because right now we're seeing the project assignment, so we can use through. All right, and then you can specify the attributes from that junction table that you want to see. Right, for example, if you put in here user ID, actually it should be in quotes. It should only see the user ID instead of all of the project ID attribute as well. So if we go up here, right, it's still giving us the created at and updated at and the project and user ID. We don't want any of these attributes from the through table, so we could just make this a blank or an empty array, and that should fix it. So you see for Octavio, again, we've got his ID, his email, his password, timestamps, a list of projects, right, and that's an array, right, it's still giving us the project assignments. We don't want it to do that. Okay, I think I'm not using this correctly, I think. See what that does for us. Okay, good. So you can see here we've got Octavio, we've got his list of projects, and then we no longer have the project assignments, which is good. So his list of projects has the 2 projects he's attached to. Right, and that goes all the way up until here. All right, good. So we're basically getting the data that we need in order to send our data through to our resolvers and have it be displayed correctly at our GraphQL endpoint. All right, so what we'll want to do is not include the password, of course, and we'll want to put this data into the shape specified by our user type in our GraphQL schema, right? Except for we're not going to display this. Right, so we'll need an ID, name, email, and a list of projects. And so what we can do to get it there is to, well, first let's make this schema file a TypeScript file. It should change nothing just by doing that. Okay. So in our utils file, we'll create one interface. All right, because we're going to basically make sure that we're getting our data into the user type shape that we want, right? So we can say interface use, let's make it lowercase user, because we don't want to confuse it with the model user, which is totally different, because in our database there isn't a list of projects in the user record. All right, so there will be an ID, of course, which is a string. There will be a name, which is a string. There'll be an email, which is a string. Then, of course, there'll be a list of projects. Let's call it with a capital P. Actually, let's do this first. Let's go project. And this will be an array of projects. All right, so the problem is we now have to define a project type. So we can do that right up here. Okay. All right, so now what we'll want to do is let's call this user data. Right, so for each user, and already you can see TypeScript is not liking this. So we need to give this user a type, but that's easy because we just created it. So this sorry, that's not what I wanted to do. So this user type will be user. Okay. All right, and then we want to return so we'll need, of course, the user ID, sorry, I'm not even thinking correctly here, ID, which will be user ID, the name, which will be user name, the email, which will be user email, and the projects, which will be user dot. Now, if we just do projects, we're not being correct here. This is, all right, so when we looked at our user data before, this is why I hate leaving the dev server running, because it does this. All right, anyway, let's just comment this out for a minute. All right, so when we looked at the data, we saw that that field for projects, right, it had a capital P, right? You can see that here. So it's not lowercase p. So that means here, this would be user.projects. Right, but now we're getting an error, right, because this doesn't exist on the type user, right? We set a lowercase value in our user type here, so what we should do is make this uppercase. Right, and that makes that error go away. So instead of console logging user data, let's see what the users look like, or the list of users. Alright, so we've got our ID for Octavio, his name, his email, and the list of projects, so that's good. Alright, so we're returning all of the information in the way that we need to return it. Okay, so all we need to do now is send this users to our resolver. Right, so we can get rid of this and just return users. Alright, but before we do, let's do a little bit more type checking. I think we've been pretty lax about it so far. Right, these three functions we don't care, we were just generating data, but here, right, think about what the output to this is, right? Say if we wanted to specify the output type, well, we see what it is right here, right? It's a user type, or it's a list of users. So if we just said, how about the output type is a list of users, TypeScript isn't going to like that. Right, it's going to say that we're using promises here, right? Because this is an asynchronous function, so we should be doing things a little differently, right? It says, did you mean to write promise array of users? And you can say, okay, I did. Quick fix. Replace an array of users with promise array of users, right? And that fixes our problem there. And, well, you know, if you want to spend a little bit more time with it, you can, but at least we did that. So if we go to our, what is it, our resolvers file, right? We're still bringing in get users, right? That's what we called the function. Right, export const get users. Okay, good. And then we're just returning that. So maybe our playground, we should be able to get what we want to get at the playground. So let's go ahead and take a look at our GraphQL Playground. All right, refresh it. All right, definitely not, but that's only because we didn't specify it. We didn't specify all the values we wanted to see, so we had name. Let's do everything though. Let's go ID, name, email, projects. Right, and remember for each project, right, we need the ID, the title, and the status. We don't really care about the timestamps, but I guess we could add them if we wanted to. We could say, for example, created at, or it's not actually sending that, so all right, forget it. We didn't define it in our user type, right? But let's just make sure everything's working for now. And when I say we didn't define it in our user type, I mean we've defined so many different types at this point you get confused, but I think you see that when you use strict type checking, that's what happens. All right, so I'm getting another call here, so I'm going to pause the video. Okay, so hopefully this gives us what we need, and it does. So for each user, we get a user ID, a name, an email, and a list of projects, right? And then for Farah, we get the one project that she was assigned to, and then for Peter, he has no project, so we get an empty array. So that's it, it's working. So you can see that with a single database query, and then a little bit of manipulation here, we get our data in exactly the shape we need it to be in, right? And when we compare that to the way we did it before in the last video, right, it's a lot less work in terms of just making the query. Unfortunately, the setup takes a bit more work, and that's one of the pitfalls of using an ORM. But the thing is you can use it, over and over again. And once you get your basic boilerplate set up, I think it's a lot easier to use, and your project will be more well structured. So that's it for this video. In the next video, we may move on, or we may actually look at another ORM. I haven't decided yet. Sequelize isn't the only ORM out there, of course, and it's actually not necessarily the most popular one, but it's been in use for a long time, so that's why I used it today. And definitely for a project like this, which I think will scale up, we'll want to have an ORM in use. I just think it makes everything look a lot better. It makes your project a little bit more well structured. And it takes a lot of the structuring work out of your hands. So anyway, thanks again for joining me, and I will see you in the next video.